Today we're going to talk about linear inequalities. An inequality is a mathematical statement containing one of these symbols. This is less than or equal to, greater than or equal to, less than, or greater than. The difference between an equation and an inequality is the symbol that you see. X equals 5 is an equation. X is greater than 5 is an inequality. When we say that x equals 5, what does this mean? It means that the variable x represents the number 5. When we state x is greater than or equal to 5, what does that mean? It means that x could equal 5, but it could also be a number bigger than 5. It could be 6, it could be 1,000,000, it could be 100, it could be 5.5. Anything greater than 5 and 5. When we say that x is greater than 5, x can't equal 5, but it can be anything greater than 5. It doesn't have to be 6, it can be 5.1, but it could also be 1,000,000,000. Anything greater than 5. Therefore, when we work with inequalities, there will always be an infinite number of solutions. Because there's so many solutions, we show the solution set by drawing the number line, because it's not a single answer. For example, if we were to graph the solution set for x equals 5, on the number 5 we'd put a dot and say, this is our answer, x equals 5. But if I were going to graph the solution set for x is greater than or equal to 5, it could equal 5, but it could also be anything greater than 5. So I would draw a line with an arrow at the end showing that it's 5, but it could also be all the numbers greater than 5. I know that that's a terrible line. I apologize. The solution set for x is greater than 5 wouldn't look just like this, because this said that x could equal 5. So we have a dot on the number 5 saying that it could equal 5. But it can't equal 5 here, so what we would do is we would put an open circle on the number 5, showing that it gets really close to 5, but 5 is not included. And it's all the numbers greater than 5. The solution set for x is less than 5 would be the same as far as on the number 5 we would have an open circle because 5 is not included. But this time it's all the stuff less than 5. Now, to know which way to draw our line, we can only follow this rule if our variable is first, like this, x is greater than 5. If it was written as 5 is greater than x, we can't follow this rule. It only works when the variable is first. So if the variable is first, then to me, this inequality symbol looks like an arrow. It looks like an arrow pointing to the right. And so that's the direction we draw our line on our number line. We'll go to the right. This one looks like it's going to the left. So we would draw our line going to the left with an arrow. Like I said, that only works if the variable is first. If it's not first, you can just flip it around to make it work. For example, if I had 5 is greater than x, I could flip everything. I could put the x first, but I have to flip the inequality and then the 5. And now these two things are equivalent, but this is the one that shows me which direction to draw my arrow. To graph the solution set for x is less than or equal to 5, this has the equal to, the line underneath it, so that means that it could be equal to 5, so we put a closed circle on 5, and x is less than, so we go to the left. So to show that a number is part of the solution, we use a closed point on the number line. So if we see an equal to or one of these lines under the inequality symbol, that means that it's equal to. That's when we use a closed point. If it's not part of the solution, if we just have less than or just greater than with no line underneath it, then we use an open point on the number. And then, like I said, if the variable is first, this greater than or equal to means shade to the right. Less than or equal to means shade to the left, the direction that the arrow is pointing. Now, the next two inequalities are called compound inequalities because they each contain two symbols. In order to graph the solution set for -5 is less than x, which is less than 5, you have to first know what this means. It's really two inequalities put together. It means x is less than 5 and x is greater than -5. These two are just put together. The x is in the middle. This is flipped over to where this part and this part are the same. If I were to flip it, it would look like this. And so it's just two separate inequalities put together. That's why it's called a compound inequality. And the way that we would graph this, whatever inequality symbol is closest to that number, that's going to tell us what kind of dot to put on that number. So on -5, since I don't have the equal to underneath it, on -5, I would put an open circle. On +5, the same thing. My inequality symbol doesn't have the line underneath it, so I would use an open circle. And x is in between these two. So I would just shade in between these two. For the next one, less than or equal to is closest to -5. So that means on -5 I would use a closed circle. And just less than is close to +5, so I would use an open circle on it. And then again, the x is in the middle, so I connect the two dots. Now, inequalities can be solved just like equations, but there's a difference. Let me show you the difference between solving an equation and an inequality. To solve this equation, I want to get x by itself, so the first thing I'm going to do is subtract 4 from both sides, and that gives me 5x equals -5. Divide by 5, so x equals -1. That means on -1, I would put a closed dot because that is my solution. That's the only answer to my equation. And to check it, I would plug that answer into my equation, where the x is. Plug in -1. 5 times -1 is -5. And -5 plus 4 is -1. And so this says -1 equals -1. That's correct, so I know my answer is correct. When I'm doing this inequality, I'm gonna work it out just like I did my equation. Subtract 4. So I get 5x is less than -5. Divide by 5. And I get x is less than -1. So it's not equal to -1. I put an open circle. X is less than -1. So it's the stuff going to the left. So when I check it, I can't plug in -1 because -1 is not part of the solution. I have to plug in another number that is part of the solution. So I'm going to go with -2. If I plug that in where the x is, we just need to see if this makes a true statement. 5 times -2 is -10. Oh, I wrote this wrong here. All right, and then -10 plus -4, that would be -6. So this says -6 is less than -1. And since -6 is to the left of -1, we know that's true. -6 is less than -1, and my solution is correct. All right, let's solve this next inequality. I want to get the x's on one side and the stuff without x's on the other side. Since I get to follow my arrow if the x is first, let me move the x's to the left side of the equation. All right, so I'm going to add 2x to both sides. And that gives me 3x plus 1 is greater than or equal to 3. Subtract 1. And that's 3x is equal to, or not is equal to, is greater than or equal to 2, and then I divide by 3. So I get that x is greater than or equal to 2/3. Well, 2/3 is not a number on my number line, but that's okay. I can just put my dot where we think that it is. So 2/3, that's not quite 1. 3/3, 3 over 3 would be 1. So it's going to be in between 0 and 1, a little more than halfway. And I would use a closed circle because I have that line underneath it. So closed circle on 2/3, and x is greater than 2/3. My arrow is going that direction, so I'm going to go to the right. Now, it's very important that you know this rule. The only step that's different when solving an inequality is that when we multiply or divide both sides of the inequality by a negative number, we have to reverse or flip the inequality symbol. What I mean by that, here we have negative 4x is greater than x. To get the x by itself, we're going to have to divide both sides by negative 4. Well, the rule just said if we multiply or divide both sides by a negative number, we have to flip or reverse the inequality symbol. So instead of it saying greater than, I need to switch it to say less than. And that would be negative 2. So to graph this on my negative 2, I would have an open circle, and my arrow goes to the left. In number 5, I'm dividing by negative 7, so to get rid of it, I'm going to multiply by negative 7. Do that to both sides, and again, if I multiply or divide both sides by a negative number, I flip the inequality. All right, this number line is not going to do me any good because it doesn't have the numbers that I need to graph. So I need to make my own. And anytime you're making a graph, you don't have to start at 0 or anything. I would just put the number that you're trying to graph kind of in the middle, and then put some numbers that are bigger and smaller around it. Okay, so on 21, I have that line underneath it, so it's going to be a closed circle, and my arrow goes to the right. Okay. Let's do a few more. Here we're solving an inequality that has parentheses, so just like with an equation, we have to get rid of the parentheses first. I'm going to distribute. That gives me a negative 6x plus 15 when I multiply negative times negative. And then distribute the 3. That gives me 3x minus 3. All right, so I'm going to want to get the x's first, so I'm going to subtract 3x from both sides. That gives me a negative 9x plus 15 is less than negative 3. And now I'm going to move the 15 over to the other side. Okay, let me write this over here. I would get negative 9x is less than negative 18. Divide both sides by negative 9. Since I'm dividing by a negative, I flip the inequality. I get x is greater than 2. Since it's just greater than, not greater than or equal to, on the 2, I'm going to have an open circle, and then this tells me I need to shade to the right. Here we have an inequality with a decimal, so to remind us how to work with decimals, just like in an equation, I can get rid of the decimals by moving them the most number of decimals to the right. Well, there's one decimal here and one decimal here, so I'm going to move them both to the right one decimal place, and this would give me 3x minus 24. Divide by negative 3. And since I'm dividing by a negative, I have to flip the inequality. And so that gives me x is less than 8. On 8, I put an open circle and I shade to the left. And then in our last one, we're going to do an inequality that contains a fraction. We're going to get rid of the fractions in a minute, but remember, the first thing we always need to do, no matter what kind of equation we have, is get rid of the parentheses. So I'm going to get rid of the parentheses by distributing. That gives me 1/2 x minus 5 over 2 is less than or equal to, that would be 2 over 3x minus 1/3. All right, the least common denominator between 2 and 3 would be 6. So I'm going to multiply everything in the equation times 6. Let's see. So if I multiply everything by 6 and reduce, I should get rid of the fractions. If I reduce this fraction, I get 3x. This would become 15. This would give me 4x minus 2. So now all the fractions are gone. Okay, so I want to get the x's on the left side. This gives me a negative 1x. Oh, how did I get 16? Okay, so I have negative 1x is less than or equal to 13. Divide by negative 1. Now I'm dividing by negative, so I need to flip the inequality, and I get x is greater than negative 13. Okay, so again, my number line doesn't go where I need it to go, so let me just add some of these. Negative 11, 12, negative 13. Okay, so on negative 13, I'm going to have an open circle, and then my line is going to go to the right. And that's how we solve and graph linear inequalities.